All right, this is what we have on page number 259. Right-hand side, hydrocarbon structure and isomerism. In the structural part, the first part is naming organic compounds, hence nomenclature. So the alkanes are a family or a homologous series of saturated hydrocarbons. By saturated, we mean they all contain single bonds. They never contain a double bond. They never contain a triple bond. The names all end en in ane. So that's the way you can understand their names. The prefixes to the names are given in table 10.1. So with one carbon atom, it begins with meth, with two, eth, so on and so forth, right? So if there are alcohols or carboxylic acid, they will be named differently, and we'll study the nomenclature in a separate way. When there is a halogen present, they are named differently. Okay? So what he's trying to do over here is to briefly tell you what nomenclature is all about. Okay? But what we are going to do over here is that we are going to do it a little bit more than what's given in the book. So in this case, what I'm going to do is that I'm going to stop sharing from here, and I'm going to start writing a Word file. Just give me a second to do that. All right. So nomenclature of alkanes. So first of all, a few names. Prefixes in alkanes. Prefixes, as we know from English grammar, is actually English dictionary, is actually the part of the name which comes in the start. There are parts of the name which come in start at the start of the name. There are some parts which come at the end of the name. The ones that come at the start are commonly known as prefixes, and the ones that come at the end are commonly known as suffixes. So what we are going to do is that we are going to bifurcate the names into different parts so as for us to make it easier for us to understand the name from the structure, or the structure from the name. So what we do is that we divide it into parts. So starting with prefixes in alkanes, and that is going to be for number of carbon atoms in the parent chain. So the numbers would depend how we are going to name it. So that is meth for one carbon. In the same way, eth for two, prop for three, but for four, pent for five, hex for six, hept for seven, oct for eight, non for nine, and dec for 10. So these are the number of carbon atoms, and that's how we name them. Do you remember the names of alkanes that we studied yesterday? That was methane, ethane, propane, butane, pentane. They were named like that. So these were the prefixes that were used in those names. Continuing.
सर जो हमने पहले प्रीफिक्सेस किए थे चैप्टर नंबर 3 में फिर वो किस लिए किए थे?
Inorganic chemistry के थे बेटा वो. That was for inorganic chemistry. This is for organic chemistry. They're totally different. Okay, that's another branch of chemistry, which usually includes the compounds that are not based on carbon. And this is another branch of chemistry, which is based on the compounds made out of carbon. Okay, whether it's carbon and hydrogen or it's carbon and hydrogen and other elements. So nomenclature for alkenes is entirely different when it comes to alkenes. They're very different from one another, and these two are not the only two nomenclatures in chemistry. There are many other different types of nomenclatures in chemistry. Okay?
Okay, sir.
Good. Good. So coming to the part where we have suffixes. Suffixes is something that comes as a bigger part. So what we are going to do is that we are going to go for suffixes in organic chemistry, not just in alkanes, because suffix is something that represents the entire thing. So what we are talking about here is alkanes are given by ane. Alkenes will be given by ene. Alkynes by ene. Alcohols by ol. Carboxylic acids by oic acids, and esters by OH. So these are the suffixes. The entire homologous series can be shown by one type of suffix. So all the alkanes were ending in A and E. Methane, ethane, propane, butane. The alkenes will be ending in E and E. The alkynes will be ending in Y and E. Alcohols, ols, carboxylic acid, acids, and esters will be by the name of OH. So that's how you are going to recognize the compound from the name. And that's how, if you have the compound in front of yourself, that's how you're going to name it. Okay? There are certain other rules of naming. I'll come to that too. But a little later. Just a second. There is one more part to it. Prefixes in alkanes for number of carbon atoms present in the side chain, or what we tend to call a branch. So that is mono for 1, di for 2, tri for 3, tetra for 4. And this is for the number of carbon atoms in the side chain or branch. Now you must be asking, what is a parent chain? What is a side chain? What is a branch? No problem, we'll answer all of these questions one by one. So in order to answer these questions, next step would be to go with the rules for nomenclature of alkanes. And that's what is going to be our next heading. So rules for the nomenclature of alkanes. All right, let's get started. Just a minute. In fact, let me stop sharing from here. And what we are going to do is that we are going to go with the sharing of the book. And we'll come back here to the document. A little bit of switching, maybe a little bit time taking or speed taking in terms of technical speed of internet, but that would help you to go back and forth in the book and what we are about to write extra from the book. Just a minute. Now, coming back to the book, the alkanes exist in a hydrocarbon side chain that are replaced by hydrogen to produce more complex molecules. In order to show where the side chain is attached, we number the carbon atoms in the chain. This means that we can indicate where the side chain is in the name. The numbering always starts at one end of the chain and the counting starts at the end, which keeps the number of the side chain as low as possible. So this is going to be one of the most important rules of nomenclature, which is also given in the book, but it's a bit messy over here. It's a bit difficult to understand without quoting a few examples and somewhat simpler examples from alkanes before even we can get started from with halogens including in alkanes. So what I'm going to do is that I'm going to go with some easier example rather than just coming to the text given straightforward in the book, which is difficult to understand. So let's go with some examples in the Word file. Just a second. So coming back to it, first of all, before I explain anything, I want you to understand this. Locate the straight longest direct carbon chain and this would be the parent chain of the molecule. See, that's how we define the chain, the parent chain. What we do is we tend to locate the straight longest direct carbon chain and that's how we call it the parent chain. Now just give me a moment in order to give an example for it. But before I do that, my internet is being a little bit unstable. Let me see what I can do with internet. Please sit patiently. Even if I leave it, then you're supposed to join it again. Take it. All right, I'm back. It's, I guess, stable now. Thankfully, I didn't have to leave the class. So coming back to that, before we come back to the Word document, I want to share something with you. I'm going to use a chemistry software over here by the name of Chemdraw. This is usually used by chemists in order to draw different kinds of structures, and I'm going to take help from that in order to explain you how this locating the straight longest carbon chain works. All right, let's come to that. Okay, if there is only one carbon atom in the chain, that would be very easier to go with. It would be methane. It is simple. Meth means one, ane represents the alkane, singly bonded, so that would be like this. CH4, that's given in the book. That's very easy to go with. That means that we are discussing about an organic compound and an alkane, which has only one carbon atom. So that's very easy to name. Okay, but moving forward, giving it another part of the structure, just a second. See, if I do it like this and add another bond over there, then what happens is that that's how it works. This is now CH3CH3, which is actually C2H6. So it's now an ethane, an alkane with 2 carbon atoms. For 2 carbon atoms, we had the prefix eth and suffix ane, so ethane. Do you get the point? In order to explain this to you, let me tell you that this is the structure and let's give it a name.
Sir, repeat कर दें.
Okay? That's how we give it a name. Now, take a look at the name below the structure. The structure is like this. It's 2 carbon atoms, hence the prefix eth. And as these are singly bonded, the suffix ane, ane. So that's how it represents. Okay? I hope you get the point. Prefix is the starting part of the name. So the starting part of the name depends upon number of carbon atoms in the chain. How many are there? 2. So it would be eth. As those carbon atoms are singly bonded, hence the second part of the name or the last part of the name, and the last part of the name is a suffix. And the suffix for alkanes or singly bonded compounds was ane, ane. So eth and ane combined together to form the name ethane. Do you get the point?
Yes, sir.
Now, let's come to some more complicated structures step by step. First of all, I explained you the alkane which had only 1 carbon atom. Now, with 2, let's come to a structure which has 3 carbon atoms. So I'm once again going to draw a structure in which I'm supposed to do it like that. So you would see that the name itself changed to propane. Why? Because now we can see there are 3 carbon atoms in the structure, hence the suffix prop. Let me come over to the suffixes for you. So for 1, we had the suffix met. For 2, we had the suffix eth. Now for 3, we had the prefix, not suffix, prop. Okay? And the suffix for alkane was very simple. It never changes. It's ane, right? So that's how we name the compounds. That's how even we are named in Pakistan. Now, try to imagine it like this. हमारे यहाँ जितने भी siblings होते हैं family में, उनके first names different होते हैं. But usually last names जो होते हैं, वो family names होते हैं, तो हम उसे change नहीं करते हैं. ठीक है? तो family name सबका उसी तरतीब से रहता है, और जो first names होते हैं, वो different हो जाते हैं. Sometimes, really, इसमें ऐसा भी चांस होता है कि first names को same रखकर last names को different कर दिया जाता है. So it's totally our choice. Humans नाम अपनी मर्जी से रखते हैं, but these are certain rules, certain patterns that we try to follow. Some families don't follow the pattern at all. First और last दोनों parts of name एक combination वाले names पे होता है, और उसमें कोई family name उसमें नहीं रखा जाता. ठीक है? Sometimes, apart from all of this, फैमिली नेम्स की बजाय कास्ट नेम्स, एरिया बेस्ड नेम्स, इस तरह की चीजें भी एग्जिस्ट करती हैं. एरियाज भी शो किए जाते हैं नेम्स के साथ, कास्ट भी शो की जाती हैं नेम्स के साथ. सो दीज आर ऑल पार्ट्स ऑफ द नेम. दिस इज ऑल nomenclature, the art of naming. In our case, as we are studying alkanes today, the suffix is not going to change and will remain ane, but that comes at the end of the name. So the prefix will change as per the number of carbon atoms. So in case of 3, we have prop. In case of 4, we have but, and we're going to say the same thing in this software. All right. Do you understand the one with the 3 carbon atoms? So I can move on to the one that has 4 carbon atoms. Do we get it?
Yes.
Yes, sir.
Good, good. Let's move on to the one with 4 carbon atoms. This is like the one. It automatically names it as butane. Take a look. That this has 4 carbon atoms. All carbon atoms are singly bonded, say. So 4 prefix but, singly bonded suffix ane, a combination will give us the name butane. Moving on, now I'm going to go with a compound that has 5 carbon atoms and hence the name pentane, right? So the list would go on. No matter how many more carbon atoms that I tend to, just a second, CH2, 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 this is already CH2. I tend to add to it, it becomes, the name changes, and that's how we put it. So what your work is to do this. Let's do it like this. Look, what your work is to actually make sure that you try to mark the whole chain, the straight longest carbon chain, direct carbon chain. How come? This is the straight longest direct carbon chain because it contains all the carbon atoms in the structure in a straight way. Why? They are bonded to one another with a step-by-step single bond in between the first and second carbon, single bond in between the second and third, in between third and fourth, fourth and fifth, fifth and sixth, and the list goes on. Okay? So in that case, that's how we try to fix them up. We also studied back in the book that we number them. We can number them either from left to right or from right to left, and that's how we can come up with the number of carbon atoms. So if we number it like this, this is 1, this one is 2, this one is 3, sorry for my poor writing, this one is 4, this one is 5, this one is 6, okay? Or we number it starting from here, this carbon is first one, this is second one, this is third one, this is fourth one, this is fifth one, and this is sixth one. Take it. Both the ways of numbering give us the same number of carbon atoms, hence 6, hence prefix hex, hence suffix with because of single bonds ane, hexane. The name remains the same. So the numbering seems somewhat insignificant if the structure is very simple and straightforward. What if the structures are not as simple and straightforward? What if they have branches on the top or the bottom of the structure? What would happen then? So
Sir,
in that case, our rules will be different. G.
सर जैसे सर इसका है हमने हेक्सेन पढ़ा है सर, तो सर अगर इसमें बाकी सब में सिंगल बॉन्ड हो लेकिन कोई एक ऐसा पेयर आ जाए जिसमें डबल बॉन्ड हो, फिर उसको कैसे नेम करेंगे?
फिर वो अल्कीन बन जाएगा और उसकी नेमिंग अल्कीन की तरतीब से होगी. That will do in the topic of alkenes. Containing even one single double bond converts the entire structure into an alkene. Alkene is a separate homologous series, different physical properties, different chemical properties, even different nomenclature. So that's why we study the families one after another separately, because even introducing a simple type of bond difference, the entire family changes. Its physical, chemical properties, its naming is different, and also other things are different. What are the things? We'll study the things about alkenes first, then we're going to study the same things about alkenes. I'll do that tomorrow, not today. Okay? Not even tomorrow, I guess the next week, because this week is pretty much loaded with nomenclature only. Clear?
Yes.
Okay, so moving back to this structure, what I just did seemed insignificant for a straighter structure. So numbering is not important in case of a straighter structure. So let's remove this numbering because this is really not needed, right? This structure can simply be taken as the numbering of carbon atoms, which you can do by just taking a look at it. You don't need to circle the whole thing. You don't need to number the whole thing. Actually, just count the number of carbon atoms by a simple naked eye view and write the name by joining the prefix and the suffix. Are we clear? So this is as much as rule number 1 goes. See? We are going to start with rule number 2 tomorrow, because rule number 2 has many variations, and we'll study rule number 2 tomorrow. In rule number 2, what we are going to introduce is that we are going to, in fact, we can study the rule number 2 right away. We're going to study the rule number 3 tomorrow. As for the number of carbon atoms in the structure, take the prefix and combine it with the suffix the structure shows, and you get the name. And I've already discussed the examples for today. So the first 2 rules are done by today. In this case, we know how to take a look at the molecule. We know how to number the carbon atoms, pick the prefix, combine it with the suffix, and the suffix is usually shown by the structure. Here we can write the type of bonding, because here the type of bonding was important, as it was singly bonded. So we named it as ane. But if there was a double bond, it would become ene. If there was a triple bond, it would become ine. Ayan, your question. Alkenes are the ones with double bonds. Alkynes are the ones with triple bonds. If there is a double and a triple bond both present, it would be a mixture of alkenes and alkynes. Okay. Then we're going to discuss alcohol separately, carboxylic acids, esters. We're going to discuss all of these families one by one. Every family will take 2 to 3, 4 days. So organic chemistry, chapter number 10 is a big chapter, because doing family by family, it takes about 3 to 4 weeks, sometimes less. See? So these are the first 2 rules of nomenclature. Are we clear with the first 2 rules? And can we name at least the most simplest of structure, just like the ones that are given in the first or second figure of the book? Let me show you here that we discussed yesterday. Just a minute. These ones. Now, you would understand how we named these ones as methane, ethane, propane, butane. Okay? I hope you understand that. Now, I think we're done for today. If you have any questions, please ask. If not, that I'm going to wind up the class. All right. Take care, class. Allah Hafiz.